Alright, I'm going to go through these pretty quick. We're going to do two sets of these. So first one, just exponentials and their graphs, what their graphs look like. We'll do some transformations along with that. And really, that's about it. So I'm going to go right down here to number 4. The rest of the stuff on the calculator, you can figure that out on your own. Not too worried about it right now. It's the graphs of the exponential function I'm worried about. So I'm just going to graph this one right here. Okay? So to graph that, I don't know what your teachers have taught you in the past, but I care about 3 points. Okay? I care about the value at -1, 0, and 1, because that is going to tell you the story. That's going to tell you whether we're increasing or it's decreasing, and how much we're increasing by or how much we're decreasing by. So I always take the parent function, which is this right here. Parent function means there's no transformations. There's no rights, no lefts, no ups, no downs, no flipping, no multiplying by a scalar value, none of that. So if I plug in a -1, who here remembers what 2 to the -1 is? It's 1/2. Very good. 2 to the -1 is equal to 1/2. Negative exponents do not spit out negative values. They spit out reciprocals, essentially. Okay? What's 2 to the 0? What's 2 to the 1? So at -1, I'm going to go up 1/2. At 0, I go up 1. At 1, I go up 2. I can tell right there, am I increasing or decreasing? I'm going to be increasing. So I'm going to draw this. By the way, there's always a horizontal asymptote for exponentials at 0. Okay? For the parent function. Now, obviously, if we move stuff up and down, that asymptote goes up and down with it. But for the parent function, it's going to start at 0, and then you go ahead and sketch this. I don't sketch too much of it. I just sketch that much. That tells me enough. Okay? So that's increasing. So I'm going to write it right down here, because it's going to ask me real quick what the domain and everything is each. So this is increasing. What's the domain from left to right? All real numbers. I'll write an interval notation for you. So all of these will be this, negative infinity to infinity for all exponentials. The range is what's different. The range, you have to look at the asymptote. So what's the lowest number we can hit? Can we actually hit 0? So we get parentheses 0 to infinity. Did I tell you anything new in this 2 minutes and 30 seconds of me talking to you? Perfect. Let's do number 6. So I'm going to do 6, and I'm going to graph it. Same thing, the parent function. I'm going to do my x and y chart. This is going to tell me everything I really need to know before I do any transformations. Always pick -1, 0, and 1. I get that question of, why'd you pick those numbers? Well, they're the easiest numbers to plug in. And that tells me what's going on the left, what's going on the right, and what's going on in the middle. And the middle should always be the same. So 0.5, isn't that really 1/2? So what is 1/2 to the -1? It's 2, because it's the reciprocal. What's 1/2 to the 0? 1. And then what's 1/2 to the 1? Horizontal asymptote. And then this really looks like the same graph, doesn't it? Except it's just... I could have drew a better graph than that. Oh well. This is decreasing. The domain, what is that? Negative infinity to infinity, because all exponentials have the same domain. You can plug in any x value and it'll spit out something for you. The range, 0 to infinity. Okay? Good so far? Alright. I'm going to kind of, sort of ignore this stuff over here. And I'm going to just do this real quick, because I want to talk about some important stuff. So, a to the bx plus c plus d. This is going to tell me all of my transformations. Okay, so I'm kind of ignoring the stuff over here. I'm going to write it like this. So b to the x is my parent function. That has no transformations on it. But as soon as I multiply something in front, add something or subtract something up here, or add or subtract something right here, stuff changes. So if I put a number in for an a value, that's going to be a vertical stretch or shrink. Okay? The vertical stretch, shrink. If a is negative, what happens if it's negative? Then it reflects over the x-axis. A is the most complicated one. C and D are pretty simple. What does C represent? Left or right? I could be more technical with that, but I won't. And what does D represent? Up or down? So left or right, it's always opposite. So if this was like an x plus 1 up here, would that be right or left? It'd be left 1. Anything that's tied with the x is the opposite. Let's talk about B real quick. If B is greater than 0, that means that we're going to have numbers like 2, 3, 4, 5. It's going to be increasing. If B is less than 0, then that is going to be decreasing. Did I tell you anything new? Alright, let's just go through some of these. So for number 8, describe the transformation. What's the parent function, by the way? You don't need to write that down, but I'm writing it down because I'm going to overkill it. Oh, it even mentions it right here, too. So what's going on? What's the transformation going on here? Right 2. What about 9? We're going to have two things. Actually, it does not matter what order we do it in. We're going to reflect over which axis? And we're going to... I like the word shrink. It's shorter and I'm dumber. Okay? Shrink. Y'all use the word compression. That's cool. I don't know if it'll be on multiple choice or not. I use the word shrink. I don't like writing down letters, so it's less than everything. At some point, you're going to realize that my laziness is really just an overkill. Okay. Oh, spiral shrink of 1/2. Probably should put the value. Number 10, this is actually one we didn't talk about. Yeah, if it's negative up in here, this is going to reflect over y-axis. Which means it actually is going to be, since this was originally increasing, it's going to flip horizontally, so it really becomes decreasing. And what's the other thing I do here? Up 3. And order does matter that you put these in. Especially with the vertical, anything vertical, because that's usually the order that people mess it up in. Like, for instance, if there was like if we were supposed to like reflect this, if you moved it up 3 then reflected, you would have a problem. Right? Versus reflecting it then moving up 3, because those would not be the same things. So always go in PEMDAS order. So you do what's the parentheses or the x. There's none. So you do the exponent first, then you do the thing that's multiplying by it, and then you do the adding or subtracting. All right. Let's do one of these problems. Solve for x using a 1-to-1 property. All that means is create the same base. So, what base do these two have in common? And I can only go down. I can't go up. 2. So how can you rewrite 16 so it has a base of 2? 2 to the power 4. Once you do that, those 2's cancel out, and you're left with 4 equals x plus 2. X equals 2. Remember we learned about the natural number e? Did you do that last year? Okay. all you really this is just telling you to plug in the calculator. I'm not gonna even worry about you doing that or even the transformations of that because it's not really gonna change anything we've done. All right. So I'm going through this like super fast because this is stuff that you should already know. Compound interest and stuff like that. Did you do that last year? You understand it's just a formula that you just plug in? Can we just move on to the next set of notes? Next. That's a dramatic effect. I would like that back. That's the $1 million question. I don't know. New to this school. At my old school, we gave it to you. At this school, I don't know. I'll have to ask. Depends who writes the test. If it's Sister's bench now that writes the test, it's going to be so hard. He writes the hardest test. It's just totally unfair. Okay. I just want to talk about, real quick, going from logarithmic form to exponential form. These are big words for me, okay? So, have you ever seen the loop before? The loop. I said this to my calculus students. They're like, the loop? Well, here. I'm going to loop everything for you. You always start at the base. So, a to the y equals x. And that's how we transform from here to here. So, a to the y equals x. A to the y equals x. So, what would this one be? 3, 2 equals 9. So this would be 3 to the 2 equals 9. Which makes sense anyway, right? And we can actually loop it here too. What's the base right here? So 5 of 125 equals... So log base 5 of 125 equals 3. And that, my friends, is how you loop. What did you do before? I think you did like Ben, right? Base, exponent, number. Yeah, well, this is more user-friendly. All right. Hey, at least you got something on it today. You can always loop it. Evaluate each log. This is just a really dumb way to ask you what is log base 4 of 16. And if you ever don't know, if you're totally lost, I always do this. Equals question mark. My dumb algebra 2 kids loved this when I taught it. I was offended by what I just said. Okay. So 4 to the question mark equals 16. So 4 to the what gives you 16. So the answer is 2. Do I need to keep going, or are we good here? I'm good. If there is no base, it's just a base 10. Hopefully remember that. Here is some stuff. So anything that's a log base 1 is equal to 0 because I said so. I mean, let's loop it. Let's figure it out. If I were to loop it, you're going to get a to the 0 equals 1. Does it matter what my a value is? Anything to the 0 is always equal to 1. I don't know if that's really what's supposed to go in there, but I just because that. Alright, for number 2, I'm going to do the same because. Yes, my grammar's not good. Deal with it. So a to the 1 equals a. Well, no, duh. So if you have the same base and the same inside part, you're going to equal 1. And these are just inverse properties. And you can loop it to figure out that yes, that is so true. They're just inverse properties of each other. I can prove it through just looping. You literally can just stare at me as I go, figure it out, right? And the one-to-one property, they have the same base and everything. They're just, the insides are equal. Nothing new. Just look at the fastest I've ever taught this class. Do I really need to go over anything else? If I want to. Let me look, see what's important. Hey, I'll do 13. Yeah, your next skills check isn't for a little bit. So, I'm not giving another skill check before the end of the 9 weeks. Okay, so your 9 weeks grade is pretty much frozen unless you want to do a retake. Those of you that have like 97s and above, I see you dancing back there. I got 97. Woo, I'm done. For 2 weeks. Okay, so these have the same log values, so you can just cancel them out, correct? So what does this actually equal then? 4 minus 3x equals x plus 2. Capiche? Alright, add 3x to each side. I'll take away 2 from each side. I'm going to get 2 equals 4x. X equals? Is this too fast for you? Hey, it says when a graph on the same thing. I'll do that real quick. I'll graph. I'll do it. Okay, so when I graph, let me zoom out a little bit here so you can see everything. When I go to graph this one, A, how do I graph it from the last lesson, which was 5 minutes ago? -1, 0, and 1. My base is 10, so I'm going to get 1/10, 1, and 10. So this is increasing very quickly. Logs and exponentials are inverses of each other. So when I graph log, I'll do this in blue. I still use the same numbers, -1, 0, and 1, but on which side do I put them on? Switch them. So just going backwards, this is 1/10. This is 1, and this is 10. So I'm going to get like over 1/10, down 1, 1, 0, and then 10, 1. And instead of a horizontal asymptote, I have a vertical asymptote. And then kablam, I'll graph it. You can do all the domain range stuff on your own, not a big deal with that, right? We're cool. Am I going too fast, too slow, just right? I don't really care about your opinion because I'm doing the same thing no matter what I'm doing. This is just transformations. We just talked about that a little bit. And then the natural E, not a big deal right here. Just ln means log base E. Okay? See, did anyone ever tell you why E is important? Okay, me neither. I won't either. No, I'm kidding. I will. The rest of it I feel like is fine, so we'll be able to finish the worksheet. Totally fine. And then next class I'll go over this a little bit more because I got to get the snapshot in. Hey, this is why E is important. E is because the value of E is the same thing as its rate of change. So, like, at x equals 2, what's the value of E? It's E squared, which is like 8-ish. If you were to draw a tangent line at E, so like here's E, right? Whee! So let's say this is the point right here, 2 comma E squared, which is like 8-ish. If I were to draw a tangent line, the slope of that tangent line would also be 8-ish, which is like totally unique. Totally awesome. When you get to calculus, I'll talk about it more, and you'll get excited for 10 seconds, and then you'll stop faking it. Alright? You good?